Hello friends, welcome to our channel. In this session, I would like to explain the concepts of design of reinforced concrete structures. So as we all of know that concrete structures has become very common in civil engineering construction. So it has established as a universal building material because of its high compressive strength. So we know that concrete is weak in tension and strong in compression. Its low, its low tensile strength is compensated by introducing steel reinforcement in the tension zone. So what I am saying means, so we know that concrete is weak in tension and very strong in compression, but its low tensile strength is compensated by introducing steel reinforcement in the tension zone. Thus the concrete is strengthened by steel and the resultant composite mass is known as reinforced cement concrete, which is RCC. Then if people know that what is concrete, so it is the mixture of, see here, concrete. Concrete is the mixture of cement, coarse aggregate, fine aggregate and water. So what is cement? It is a binder, means a substance used to make other substance mixed together, which is binder, and coarse aggregate, which gives strength. Fine aggregate means some void filler here. And what about water? Water is the hydration plus workability. Again here, hydration, the process of causing something to absorb water. And what is workability? Compacted easily without segregation of water here. So concrete is the mixture of cement, sand, coarse aggregate, water. Again cement is the binder, the substance which used to make other substance mixed together, and coarse aggregate for strength, fine aggregate which is the void filler, and water gives hydration and workability. Then we will discuss about the steel. So there will be two types of material based on the steel will be available. One is MS, which is mild steel, which is denoted with Fe 250. This Fe for ferrous metal, ferrous, Fe RROUS. So this 250 is yield strength in megapascal, which is yield strength in MPa. And again in HYSD. What about HYSD? That one will be high yield strength deformed bars. In that there will be two types. One will be Fe 415, another will be Fe 500. So in the steel there will be two types of material, which is one will be mild steel, another one will be HYSD. So in that we will available will be Fe 250, that is ferrous, Fe for ferrous, and this 250 is yield strength in megapascal. So one will be Fe250 material, another one will be in the HYSD bars Fe415 and Fe500. Here also Fe for ferrous metal and 415, and which is the yield strength in MPa. But this MS450 is not recommended because of its poor strength. Okay, so generally we are using these two. One is Fe415 and Fe500. So whether if they ask any question like that Fe415 or like that, means you can denote with the Fi, which is yield 450 in terms of Newton per mm square, like that. Then what are the material which is easily available in the market? So in MS, plane, which is 6 diameter bar will be available. So that is plane. Okay, then HYSD bars. So I am writing here HYSD bars. So it will be in the form of ribbed or corrugated, like this. So it will be in the form of ribbed or corrugated. So the diameter of the bars minimum it will be available in the market will be 8 taken from 8 again 10 12 16 in again 20 25 32 and higher diameter bars. So these are the bars which will be easily available in the market, and the length. So nowadays these HYSD bars will be replaced by thermomechanically treated bars, which is TMT. So TMT refers to the thermomechanically treated. So these bars will be replaced by the thermomechanically treated bar. So even though the chemical composition is similar in both TMT and HYSD bars, and at the same time length of the bar. So what is the length of the bar? So the length of the bar will be 40 feet in terms of feet, or it will be in 12 Okay, if it will be straight means, if it will be straight bar means it will be in the form of 40 feet or 12 So it will be form of U shape. So it will be the form of U shape means like this. It will be in the form of U shape means, or U bend. So this is straight rod. So it will be form of U bend means, so the diameter, the in terms of feet it will be some 18 to 20 feet, and here it will be, or in terms of feet it will be 5.5 to 6 feet. So you please remember the length of the bars also. Generally it will be some 40 feet to, which is in 12 so the mark it will be easily available just like the form of U bends only. So you can share that rods. So already people know that one. So I also explained that ranges also. Then go to the next topic, which is compressive strength. compressive strength or grades of concrete. So the compressive strength of concrete is the characteristic strength of the concrete, which is denoted with FCK. So what is this FCK? Which is characteristic compressive strength of concrete. So the compressive strength of concrete is the characteristic compressive strength of 150 mm cubes at the age of 28 days in Newton per mm square. So the characteristic strength is defined as the strength of the material below which not more than 5% of the test results are expected to fall or expected to fall. See here, what is compressive strength of the concrete? So it will be denoted with FCK, means characteristic compressive strength of the concrete of 150 mm cubes at the age of 28 days in Newton per mm square. Means the characteristic strength of is defined as the strength of the material below which not more than 5% of the test results are expected to fall. So according to IS 456, so this is Indian standards. IS means Indian standards 456 to 2000 specifies the characteristic compressive strength of 150 mm cube. So 150 mm means, so that is mold of some 15 centimeters, 15 centimeters, and again in the width wise also it will be 15 centimeters. So it is in the form of cube, lengthwise, breadthwise, and width, height. It will be in the form of 15 centimeter by 15 centimeter by 15 centimeters. Like that, in terms of mm, it will be 150 mm cube at the age of 28 days in Newton per mm square. Means the grade of the concrete will be varying from 50 into 80 Newton per mm square. So designated as M15 to M80, like that. Based on the characteristic compressive strength, concrete is graded. So I will show that format. So it will be graded like this. See here, I will show you in the form of the table format. So here, group, and here it will be grade designation. Here I am simply writing FCK, means characteristic compressive strength of 150 mm cubes at the age of 28 days in Newton per mm square. So I am just writing FCK, means which is characteristic compressive strength of concrete. So what are the groups here? So they will be divided as ordinary. So ordinary concrete, and again here standard concrete, and this will be high strength concrete. So this ordinary concrete, what are the grades comes under this ordinary concrete? So in the grade designation, so it will be M10, M15, M20. And what are the grades comes under here? M25, M30, like that up to M55. M55. So these are the grade designations which will comes under the standard concrete. And again here, so this is 5. Here taken from M60, M65, like that M70, 75, and again up to M80. So increase 5 numbers here also 25, 30, 35, 40, 45, 50, 55. Like that these are the grade designations which will comes under this concrete. And what about the characteristic compressive strength for this one? So what I am telling, so M10 means directly at the age of 28 days in Newton per mm square will be just 10. So whatever the number here you have, so take down that number. That's what I am saying here. Here it will be 15. Here it will be 20 for this one. This one for 25, 30, like that so on, and 55. So means the characteristic compressive strength of 150 mm cubes at the age of 28 days in Newton per mm square is 10 for the grade designation of M10. And what about this M? This M refers to the mixer. And what about this 10? This 10 for the number to the characteristic compressive strength of 150 mm cubes at 28 days in Newton per mm square. So these are the grades of the concrete. And again I will show you minimum grades of concrete of different exposure conditions. Minimum grades of concrete for different exposure conditions. So again I will show this also in the form of table format. So exposure and the minimum grade of concrete for RCC. Grade of concrete, that is minimum grade of concrete for RCC. So what are the minimum grade? So generally we are taking minimum grade of concrete to be taken from M20 itself directly, that is M20, and again M25, M30, M35 and M40. So what are the exposure conditions here? So M20 will be using for mild, and here this one will be for moderate. So you please remember all these things, maybe it will be asked in your competitive examinations like that. Severe for M30, and this one will be very severe for M35, and extreme for M40. So these are the minimum grades of concrete for different exposure conditions. And again, so I will show you how to remember the mixed proportions for nominal concrete. So nominal mixed proportions taken from M5 to M20 and above. So I will show you that also. So before that I will explain the relation for the tensile strength. Tensile strength. The tensile strength, so already I told in the first step itself, concrete is fairly strong in compression and weak in tension zone. So therefore, the tensile strength of the concrete is very low, and hence it is not taken into account in the design of reinforced concrete. So, but it is an important property which affects the extent and width of cracks in the structure. So, according to our Indian standards 456 to 2000, the tensile strength of concrete can be calculated from the compressive strength using the relation that one will be FCR equal to 0.7 square root of FCK Newton per mm square. So all these relations you will get in the code book also. So you please remember. So for what is the relation for the tensile strength? That one will be equal to FCR equal to 0.7 square root of FCK Newton per mm square. So already I told you what is this FCK, which is given as characteristic compressive strength of concrete. For example, if we based on the exposure conditions, they will given for M20 like that, means you can directly substitute FCK will be equal to 20 here. So 0.7 square root of 20. So what is the tensile strength for M20 grade concrete? So you can directly tell the value, the tensile strength will be equal to 0.7 square root of 20. So you will get the value directly. And at the same time, modulus of elasticity. Modulus of elasticity. So modulus of elasticity of concrete is an important property required for computation of deflections of structural members. So it is the important property required for computation of deflections of structural concrete members. So what is the relation according to our Indian standards? It will be given that one will be equal to 5000 square root of FCK in Newton per mm square. So what about this EC? EC is the short term static modulus of elasticity. Modulus of elasticity. So elasticity. Okay. Then I will explain the mixed proportions ratios. So nominal mix proportions for different grades of concrete. So here it will be grades of concrete, and here it will be nominal mix proportions. So this is the different grades of concrete. So I am taking from M5 and M7.5, M10, M15 and M25. So I will explain you one simple trick how you people remember this nominal mixes directly. So nominal mix means it is the proportion of cement, sand and aggregate. Okay. So for each and everything, cement will be one common. So you please remember like that. So I am taking 1, 1, 1, 1, 1. And again, so here there will be one number which is 5. So I am as it is taking here 5 like that only. Okay. Then from here onwards, you decrease the number like this. Here it will be 4. Here it will be 3. Sorry, here there will be M20. Okay, here also you will take 1 and 2 and here 1, and again there will be one number which is decreased to some 1.5 and 1. So up to here you decrease 1, 1, 5, 4, 3, 2 and again 1.5 and 1. After that, what about the aggregate? So whatever the sand here, aggregate will be equal to 2 times of sand. Whatever the sand, just multiply with 2 times, means 5 into 2, 10. Here it will be 4 into 8, 2 8, 3 into 2 6, 2 into 2 4, here 1.5 into 2 3, here 1 into 2 2. So these are the mixed proportions for different grades of the concrete. For example, M5. M5 means 1 is to 5 is to 10, and M7.5 1 is to 4 is to 8, and M10 1 is to 3 is to 6. I am just telling the logic in what way you have to remember easily. Then for M20 it will be M1 is to 1.5 is to 3, and M25 will be 1 is to 1 is to 2. And what about M30 and above? So which can be design in the field directly, and you will get that proportions. But whatever the standard values, you please remember like this in the logical way, then it will be easily remember to you. Then going for the next step, which is designs, different methods of RCC. Okay, methods of RCC design. Methods of RCC design. Okay, so what are the methods of RCC design? First one will be working stress method. Working stress method. Second one will be ultimate load method, and third one will be limit state method. Limit state method. So according to our syllabus, so nowadays we are preferring only limit state method for the design of RCC. So that is the reason I will explain briefly about the limit state method, but just we will know the formulas based on the working stress method and ultimate load method also. So first I will discuss about the ultimate method very briefly. See here, working stress method. So what is working stress method? Here, working stress method is also called as, so elastic method. This working stress method is also called as elastic method. Again, modular ratio method. Modular ratio method. Again, factor of safety method. Factor of safety method. So here whatever the loads we are considering means design loads equal to working or service loads. For example, if you talk about the ultimate load method, means there will be design loads or ultimate loads or service loads. Collapse loads. But here design loads will be based on working or service loads. And again, design stresses means allowable stresses or permissible stresses will be equal to characteristic strength of material. Characteristic strength of material by factor of safety. Means design stresses will be equal to characteristic strength of material by factor of safety. And again, factor of safety in beams will be equal to, in working stress method, for concrete it will be 3, and for steel it will be 1.78. So these are the important things we have to remember on the working stress method. Then move for the ultimate load. Ultimate load method, which is second one in our topic. So here in the ultimate load method, so what are the design loads will be based on? So the design loads will be based on the ultimate load or collapse load. So here I am writing that one. The design load will be based on ultimate load or collapse load. And what about in the working stress method? The design loads will be based on this working or service load. Okay. Then here the load factors depends upon load factor depends on load combinations. Load combinations means that one will be equal to ultimate or collapse load means working load or service load into load factor. So here the design load will be taken as working load or service load into load factor. But here in the working stress method directly you can take down that working or service load. So that is the small difference here which we have to remember. Again, the design stresses will be equal to here the design stresses will be equal to or allowable stresses or permissible stresses, same as the working stress method, which is characteristic strength of material material safety factor, characteristic strength of material by material safety factor. And again, material safety factor in beams will be equal to, again in concrete it will be 1.5, in steel it will be 1.15. So these are the important points which we have to remember in the ultimate load. At the same time, I will show you one more note point here. In the working stress method, so here we are in the working stress method. In this working stress method, design load is based on the uniqueness theorem. Uniqueness theorem. And again, design strength is based on the lower bound theorem. So in the working stress method, here what about in the ultimate load method? Design load will be based on upper bound theorem, strength of material based on the lower bound theorem, which is lower bound theorem. Here serviceability is not considered in this method. In this ultimate method load method, serviceability is not considered. Therefore it has not become popular. So you please remember all these important points regarding these two methods. So I will explain one more time. So working stresses method is also called as elastic method, modular ratio method, or factor of safety method. Here design load will be equal to working or service load. Then design stresses will be equal to characteristic strength of material by factor of safety. So what is the factor of safety? Generally here we are taking for concrete, it will be 3, and here it will be 1.78. Then coming to the ultimate load method, so design loads will be equal to ultimate load or collapse load. Means here load factor depends upon load combination. So that one will be equal to working load or service load into its load factor. Then design stresses will be equal to characteristic strength of material by its material safety factor. And again the values you please remember, there it will be 3 and 1.78, but here in the ultimate load method it will be 1.5 and 1.15. And one more 2 points what we have to remember here, design loads will be based on uniqueness theorem and design strength will be based on lower bound theorem in the working stress method. Coming to the ultimate load method, design load will be based on upper bound theorem and strength of the material will be based on the lower bound theorem. So here serviceability is not considered, therefore this material it has not become popular. Then coming to the limit state method, generally we are doing designs from these only, from this limit state method only. So limit state method, our next topic is about the limit state method. So what is here? Means limit state is a condition, that is a condition just before collapse, just before collapse. Means limit state is a condition just before collapse. Up to this condition, means up to this condition the member is safe to resist external loads. Means up to this condition the member is safe to resist external loads and also gives proper service throughout its life, and also gives proper service throughout its life. Okay, again this limit state method will be divided in two types. One will be limit state of collapse, so another one will be limit state of serviceability. One will be limit state of collapse, another will be limit state of serviceability. Again what are the things comes under this limit state of collapse? So first one will be flexure, so flexure for bending in beams, and again shear for beams only, and again compression for columns and shear for beams. So here also I am mentioning flexure, bending for beams only, and again torsion, fourth one will be torsion, means end or L beams, so which is end, at end L beams or beams curved in plan. So L beams or beams curved in plan. Then coming to the limit state of serviceability, so there will be again cracking, deflections, durability, fire resistance, and vibration. So these are the conditions which we will get in the limit state of serviceability and limit state of collapse. And again, here design loads will be based on design loads or ultimate load or factored load, and again limit load or collapse load. So that one will be, which is denoted with here FD, that one will be equal to characteristic load, characteristic load into its partial safety factor, which is denoted with gamma f, where gamma f will be equal to partial safety factor, means design or ultimate or factor load will be equal to characteristic load into its partial safety factor. So simply please remember that FD will be equal to characteristic load will be defined with F into partial safety factor as gamma F. So here what is characteristic load? The load which has the, again I am taking about what is characteristic load. So characteristic load is the load which has 95% probability of not being exceeding, probability of not being exceeding in the life of the structure, not being exceeding in the life of a structure is characteristic load. So what is characteristic load? The load which has a probability of 95% probability of not being exceeding in the life of a structure. So there will be some small problems based on this characteristic load also. If I will show you that one, means you will get a clear idea based on the characteristic loads also. Okay. See here characteristic load. So I am showing you in the form of graph, some approximately rough graph. So here it is not possible to draw accurately as it is. So you please adjust here. Means like this you will get the graph. So here also like this. Okay. Means here 95% means I am just removing this 5%. So this is 5% and remaining this one will be 95%. So here 95% means entire this one, which has the probability of not being exceeding the life of the structure. And again there will be some formulas based on this one you will get. So for that one I will tell you the formulas also. F equal to means characteristic load. What about this F? That one will be equal to characteristic load will be equal to Fm plus K into S. So what about this Fm? Again this Fm will be equal to average or mean load, and K here for constant and S for standard deviation. You people know that one, standard deviation. So here I'm taking from center like this. And here also this is average main load, which is Fm from here to up to here. This K value equal to 1.65, that is constant. You please remember that K value 1.65. And what about this Fm? This Fm will be equal to sum of the loads which is given to its so on to its total number. And what about this standard deviation formula? That one will be equal to square root of Fm minus Fi. So here you will get in terms of the given values whole square by, so that is Fm minus Fi. Fi whole square by n minus 1. So don't bother about this one. I will explain one problem on this. See here, so RCC limit state is based on 95% probability load, and again payment design is based on 98% probability load. So please remember that one, and I will solve one question based on this. The live loads. So this is the questions. The live loads acting over a structure. So this is the question what I am writing here. Acting over a structure at different conditions, are given below. Here what they are asking, determine characteristic load. And what are the values given here? 30 kilonewton per meter, comma 15 kilonewton per meter, comma, and again 20 kilonewton per meter, comma 45 and 45 kilonewton per meter and 50 kilonewton per meter. What we have to find out here? So our solution will be equal to, we are going to find characteristic load which is F. That one will be equal to Fm plus K into S. We all of us know K value will equal to constant which is 1.65, and for finding Fm, what is the only procedure here? F1 plus F2 plus so on by N. So that is the formula what I told you before. So that one will be equal to, given loads will be 30 plus 15, again 20 plus 45 plus 50. So total number will be equal to 5 here. So that one will be approximately, if you simplify directly, you will get 32 kilonewton per meter. And if you will get this one, and directly, what about next point? So S value will be equal to, so we people know the formula of taking Fm minus Fi whole square by n minus 1. So as per Indian standards 456, to have characteristic values, minimum 30 samples are required to have proper correlation. But here it will be given only some 5. So see what is the value we will get. So it is under the square root itself, like that, square root of. So I am taking all the values here. So Fm is already you know 32 minus Fi means 1, 2, 3, 4 like that. So what are the values given in the question? So this one 30, 15, all the things I am simplifying here. So 30 whole square. So plus means which is in the form of summation here. That is, here I am taking sum of the Fm minus Fi whole square means 32 minus 30 whole square, again Fi minus Fi, that is 32 minus next value, which is 15 whole square plus 32 minus 20 whole square, like that remaining two numbers, 32 minus 45 whole square plus 32 minus 50 whole square, divided by 5 minus 1. So if you want here, please write down the two values also without any confusion. So I'm just giving the idea of in what way you have to calculate these things, that is 32 minus 45 whole square plus 32 minus 50 whole square. If you simplify this one, you will get 15.24. So just simplify the values. Next, characteristic load will be equal to, already you people know Fm value, which is 32 plus constant value, which is 1.65 into 15.24, which is S value. So directly you will get the value of 157.16 kilonewton per meter. So this is the procedure for finding characteristic load. So what is the characteristic load? So already I told you, characteristic load is the load which has 95% probability of not being exceeded in the life of the structure. And again we will talk about the characteristic strength of the material. So which is very similar. I will just give the hint, okay, which is very similar to this one. I will just give in the hint for this one. Characteristic strength of material, okay, characteristic strength of material. So the strength which not more than 5%, the strength which not more than 5% of test results are expected to so fall. Here in the same way I will show you that format also in the graph. So I am drawing approximate graph in what way it will be. So like this. So means here 5% of the test results means only taking 5%, not more than, means I am taking here which is 5% of the test results. So remaining things here it will be same like as the previous one, which is Fm, and total it will be 95%. And again here we are calculating K value equal to 1.65. So here it will be negative and it will be positive, like taken from left side negative, right side positive. So if you want to find a characteristic load, means F equal to Fm minus K into S, or else directly take down the value of K value minus 1.65. Okay. So just to see the difference, here characteristic load is the 95% probability of not exceeding the height of the structure, means up to 95% we are taking, and we are not exceeding up to 95% we are taking, we are not exceeding this 5%. Here not more than 5% of the test results are expected to fall, means not more than 5% means we are taking up to only this 5% and we are not taking above this 5%. So therefore we are taking from here minus 1.65, and at the same time design load greater than average, here design load which is greater than average, and again design strength less than average. Again in the limit state of serviceability, you please remember the factor of safety for concrete will be equal to 1.5, which is in limit state of collapse, and in the limit state of service for concrete it will be 1.0. Again for steel it will be 1.15, and again it will be 1.0. So factor of safety in the working stress method for concrete it will be how much I told? For concrete it will be 3 and steel it will be 1.75, and for ultimate load method it will be concrete for 1.5, steel 1.15, and for this limit state of serviceability means limit state method there will be two methods, which is one will be collapse, another will be serviceability. Means factor of safety for concrete will be 1.5 and for steel 1.15. In the serviceability factor of safety for concrete will be 1.0 and for steel it will be 1.0. So maybe you people little bit confused for comparing with the three methods. So it is better to remember directly without following any code books. Maybe in the direct examination or in the competitive examination halls you will get direct questions like this. So we can solve already one problem based on the strength of the characteristic load. So by taking the same values, you can calculate the characteristic strength of the material also. So that also given, but already I solved in the characteristic load. So no need to solve once again here. Then we will go for one more simple topics relevant to this. So I will just explain that one also. So that is the last topic in this session. So maybe it will take some 5 more minutes. Okay, see here we will talking about the combination of the loads. So we will talking about the combination of the loads. Means here one question will be there like this: calculate design load. Calculate design load. Design load in collapse. In collapse and serviceability. Serviceability separately. Separately. Okay. For dead load equal to 150 kilonewton per meter, live load equal to 250 kilonewton per meter, wind load equal to 25 kilonewton per meter, comma, earthquake load equal to 32 kilonewton per meter. Here there will be given some combination of the loads. One will be dead load, another one will be live load, another one will be wind load and earthquake load. Means in case of earthquake load, replaced wind load with EL in the combination for partial safety factors. Means what I am saying means both wind load and earthquake loads occurring together will be both wind load and earthquake load occurring critically together is impossible. That's why they are not considered together. Means if the combination will be given like this, means at a time occurring these two will be impossible. Therefore what we have to do if they will mention directly like this, means use maximum of these two. Okay, so according to the question, so first we are going for the design load of collapse. So there will be three combination according to our Indian standards only. So first combination will be 1.5 times of dead load plus 1.5 times of live load, and again second combination of load will be 1.5 times of dead load, 1.5 times of dead load plus 1.5 times of earthquake load. And what about third combination? Third combination will be 1.2 times of dead load plus 1.2 times of live load plus 1.2 times of earthquake load or wind load here. Sorry, here also earthquake load or wind load. But what I am telling means, so there will be the three combination of the load in the design load of collapse according to our Indian standards. That is 1.5 times of dead load and live load, 1.5 times of both dead load or earthquake or wind load. But we don't know. For example, in the question they will mention only about wind load, means we are taking wind load. But here they will be given to So at that time what we have to do means, we have to take whichever maximum value comparing these two. Means here 1.5 times of dead load means what we have to take dead load which is 150 kilonewton meter. So we are substituting that value directly. Here also live load which is 250 kilonewton meter. Coming to here also 150, and here what about earthquake load or wind load? One will be 25, another will be 32. That is the reason you take whichever is maximum in these two and you simplify this one. And again here in terms of dead load, one will be 150, another will be live load will be 250. And what about earthquake load or wind load? We are taking whichever is maximum. And if you simplify this one individually, one will get here that one will be 600 kilonewton per meter, and again here will be 273 in terms of kilonewton meter, and again here it will be 518 kilonewton per meter. So what is the design load of collapse here? So out of these three, whichever is maximum, we are considering that one, whichever is maximum, that is our design load of collapse will be taken as 600 kilonewton per meter. So whenever you will get in the combination of these loads like this means, you can take whichever is maximum. Means here one small logic. For example, if any structure will bear the maximum load means automatically it will bear the minimum load. That is the reason we are taking higher load in place of the these two. For whether it will be wind load is heavier than earthquake load, like 40 means we are considering that only in our designs. Then I will give just a limit state of service values, limit state of serviceability. Just I will explain the code value combinations here like previously. So for first one 1.0 means one dead load plus one terms of live load. Here one terms of dead load plus 1.0 EL or wind load. Okay, and here one dead load plus one factor means that is 0.8 times of live load plus 0.8 times of EL or wind load. Here also we are considering whichever is maximum in terms of earthquake load or live load. Again you know the dead load of 150 and live load of 250. Substitute the values. Here you will get one will be 400 kilonewton per meter, another one will be 182 kilonewton per meter, another one will be 375.6. So calculate the values exactly. Again here out of these three whichever is maximum, that is 400 kilonewton per meter in the limit state of serviceability. Friends, today I will close this session up to here. I think you got the introduction what I explained here. Thank you so much for attending my channel. See you soon in the next lecture, that is the continuation of this RCC only. Okay. Thank you so much for watching this video. If you really like this video, please like this video, share it to your friends and subscribe our channel. Thank you so much.